Hello dear students, our lesson for today is all about rocks. Rocks are aggregate of minerals. It can be composed of single mineral, for example, quartzite, a metamorphic rock composed predominantly of quartz, or more commonly, as an aggregate of two or more minerals. A mineral name can be used as a rock name like gypsum rock, which is composed predominantly of the mineral gypsum. Earth is a solid rock to a depth of 2,900 kilometers, where mantle meets the liquid outer core. A rock is a naturally occurring solid aggregate of one or more minerals. The aggregate minerals forming the rocks are held together by chemical bonds. Grains can be different in color, texture, and sizes. Geologists then group rocks into three categories based on how the rocks form: igneous, sedimentary, and metamorphic rock. Petrology is the scientific study of rocks. Rocks are combined aggregation of minerals. Petrologists classified rocks based on how they were formed. In general, rocks are classified as igneous, sedimentary, and metamorphic rock. Rock classifications. Rocks are classified on the basis of the mode of formation. The three rock types are igneous, sedimentary, and metamorphic rocks. Igneous. Igneous formed from hardening and crystallization of magma or molten material that originates deep within the earth. Two types of igneous rock: extrusive, volcanic rock, intrusive, plutonic. Extrusive, volcanic rock, forms when magma makes its way to Earth's surface as lava and then cools. The crystals are very small, fine-grained, since the cooling process is fast. Intrusive, plutonic, it cools slowly beneath the Earth's surface and are created by magma. The intrusive igneous rocks have very large crystals, coarse-grained. Magma versus lava. What is the difference? Lava is molten rock that has reached the Earth's surface through volcanic vents. Magma is molten rock stored under the Earth's surface. Did you know? Lava can also be found at the bottom of the oceans, in places called mid-ocean ridges. They account for more than 75% of the Earth's volcanic activity. Volcanic or extrusive rocks. From solidified lava at or near the surface of the Earth. Fast rate of cooling, crystallization due to huge variance in the temperature between Earth's surface and underneath. Common textures: aphanitic, porphyritic, and vesicular. Examples: rhyolite, andesite, basalt. Pyroclastic rocks, fragmental rocks usually associated with violent or explosive type of eruption. Examples: tuff and pyroclastic flow deposits, ignimbrite. Plutonic or intrusive rocks. From solidified magma underneath the Earth. Gradual lowering of the temperature gradient at depth towards the surface would cause slow cooling crystallization. Phaneritic texture. Examples: granite, diorite, gabbro. Types of igneous rocks. Extrusive, calling time, seconds to months. Texture: invisible or microscopic grains. Intrusive, calling time, thousands of years. Texture: small to medium grains. Plutonic, calling time, millions of years. Texture: large grains. Igneous rocks are classified based on 1. Composition. Felsic, light in color, feldspar and silicates. Mafic, dark in color, made up of magnesium and iron. Intermediate, between mafic and felsic. Ultramafic, very dark color. 2. Texture. Aphanitic, fine-grained. Phaneritic, coarse-grained. Porphyritic, large crystals with small crystals. Glassy, non-ordered solid from rapid quenching. Pyroclastic, composite of ejected fragments. Examples: obsidian, pumice, basalt, granite, diorite, gabbro. Metamorphic. Forms from pre-existing rocks, either metamorphic, igneous, sedimentary. Examples: quartzite, marble, slate, phyllite. Metamorphism, transformation of one rock type into another. There are two types of metamorphism. Regional, due to changes in pressure and temperature over large region of the crust. In regional metamorphism, pressure is main factor, occurs in areas that have undergone deformation during orogenic event resulting in mountain belts. Contact, mainly by heat due to contact with magma. In contact metamorphism, heat is the main factor, occurs when a pre-existing rocks get in contact with a heat source magma. Classification. A. Texture, refers to the size arrangement add grains within the rock. B. Foliation, any planar arrangement of mineral grains or structural features within the rock. Foliated rocks, bottom from shale is precursor rock. Metamorphic grade increases from slate to gneiss as pressure increases. Example, mica non-foliated, made up of only few minerals. Sedimentary. Sedimentary rocks provide information about surface conditions that existed in the Earth's past. Particles of sand, shells, pebbles, and other fragments of materials called sediments, accumulate in layers and over long period of time harden into rocks. Compaction due to increase of pressure of layered sediments it bind together to form the sedimentary rocks. There are three types of sedimentary rocks. Clastic sedimentary rock. Formed from accumulation of clasts, little pieces of broken rocks and shells. Examples, conglomerate, breccia, sandstone, shale. Chemical. Formed when dissolved minerals precipitate from a solution. Example, halite, formed when a body of seawater becomes closed off and evaporates. Organic. Rocks formed from the accumulation of animal debris. Example, coal, composed of organic matter in the form of plants' fragments. That's all for today. These are the activities that you will do this week. Day 1. Learning Task 1. What I know, page 43 to 45 and what's new, page 46. Day 2. Learning Task 2. What I have learned, page 52 and what I can do, page 53. Day 3. Learning Task 3. Additional activities, page 56 to 57. Day 4. Learning Task 4. Assessment, page 54 to 55. Have a good day.